Question number 1. A large engineering company plans to deploy a distributed application with Amazon Aurora as a database. The database should be restored with a recovery time object of 1 minute when there is service degradation in the primary region. The service restoration should incur the least admin work. What approach can be initiated to design an Aurora database to meet cross-region disaster recovery requirements? Question number 2. A company uses an organization in AWS organizations to manage AWS accounts that contain applications. The company set up a dedicated monitoring member account in the organization. The company wants to query and visualize observability data across the accounts by using Amazon CloudWatch. Which solution will meet these requirements? Question number 3. A company developers want to secure way to gain SSH access on the company's Amazon EC2 instances that run the latest version of Amazon Linux. The developers work remotely and in the corporate office. The company wants to use AWS services as a part of the solution. The EC2 instances are hosted in a VPC private subnet and access the internet through a NAT gateway that is deployed in a public subnet. What should a solution architect do to meet these requirements most cost effectively? Question number 4. A data analytics company has 80 offices that are distributed globally. Each office hosts 1 petabyte of data and has between 1 and 2 Gbps of internet bandwidth. The company needs to perform a one-time migration of a large amount of data from its offices to Amazon S3. The company must complete the migration within 4 weeks. Which solution will meet these requirements most cost effectively? Question number 5. A company uses high concurrency AWS Lambda function to process a consistently increasing number of messages in a message queue during marketing events. The Lambda function uses CPU-intensive code to process the messages. The company wants to reduce the compute cost and maintain service latency for its customers. Which solution will meet these requirements? Hello everyone, my name is Rafi Saeed and I'm thrilled to welcome you to another 5-in-1 Lab video. Today our focus is on AWS Solutions Architect Associate exam, where we will exploring latest exam questions and their solutions. I'll simplify complex concept with practical demonstration to ensure easy comprehension. But before we dive in, let me provide you with a brief overview of what 5-in-1 Lab is all about. 5-in-1 Lab is the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission at 5-in-1 Lab is to provide our clients with exceptional exam preparation experience for certification in AWS, Cisco, Huawei, Aruba, Juniper, Palo Alto, and Fortinet exam tracks. So, today we are going to discuss some interesting exam topics: Amazon Aurora, CloudWatch, Systems Manager, Snowball, and Lambda. So, let's get started. Question number 1. A large engineering company plans to deploy a distributed application with Amazon Aurora as a database. The database should be restored with a recovery time object of 1 minute when there is service degradation in the primary region. The service restoration should incur the least admin work. What approach can be initiated to design an Aurora database to meet cross-region disaster recovery requirements? Let's evaluate each option. Option A. Amazon Aurora Global Database and use the secondary region as a failover for service degradation in the primary region. Amazon Aurora Global Database allows you to create a read replica in a secondary region in the event of service degradation in the primary region. You can promote the read replica in the secondary region to become the new primary. This approach provides automatic failover to the secondary region with minimal administrative work. This seems to be the correct answer, but let's discuss available choices as well. Option B. Use multi-AZ deployment with Aurora replicas, which will go into failover to one of the replicas for service degradation in the primary region. While multi-AZ deployments provide high availability within a region, they do not automatically extend to a secondary region for cross-region disaster recovery. So, this is not the correct answer. Option C. Create DB snapshot for the existing Amazon Aurora database and save them in Amazon S3 bucket. Create a new database instance in a new region using these snapshots when service degradation occurs in primary region. Creating DB snapshot and restoring them in a new region manual intervention and may not meet the 1-minute RTO requirement. So this one is also not the correct answer. Option D. Use Amazon Aurora point-in time recovery to automatically store backups in the Amazon S3 bucket. Restore a new database instance in a new region when service degradation occurs in the primary region using these backups. While Aurora supports point-in-time recovery, it is not designed for automatic failover to a secondary region in the event of service degradation in primary region. So this one is also incorrect. For cross-region disaster recovery scenario with 1-minute RTO and least administrative work, option A, use Amazon Aurora Global Database is the most suitable choice. This approach allows for automatic failover to a secondary region with minimal intervention. Alright, so let's dive into the console and explore the process of enabling Aurora failover. Alright, so we are logged into the console and this is Amazon RDS dashboard. Let's click on DB instances. I have already provisioned my Aurora global database. As you can see there, this is already provisioned, which contains 2 regions. The primary database currently in Virginia region. As you can see there, this is Virginia region code, and this database does exist in zone A. And this one is my Ohio database, which is a reader node or read replica, so I can switch over anytime as per the requirement, or in case of service degradation in primary region, the secondary region will seamlessly take over. So if you want to add another region, you need to just select your cluster and click on action. From here you can add another AWS region as well. So you can select any region as per your requirement. There are a number of regions available. Currently the database I have is in Ohio and Virginia, but I can add any other region as per the requirement. So from here you can change the instance type. Currently the instance type is DBR6G 2x large, which you can change as per the need or the requirement. If you want to create a multi-Z read replica or a reader node, so you can create it. From here you can select your network configuration, you can select your VPC and DB subnets as well. Alright, so let's jump back to the dashboard. From action you can switch over to failover global database. Let's click on switch over. You have to select the database where you want to failover. So this is my Ohio cluster, and as soon as I confirm, it will start the process of failover. Alright, so as you can see, there are 2 endpoints, writer and reader. Both are available with my primary database engine, which is my primary cluster. It's basically support read and write both operations. So the data is now replicated across region. In case of any service degradation in the primary region, the secondary region will seamlessly take over. With Amazon Aurora Global Database, you have set up a failover mechanism to ensure continuity in the face of unexpected challenges. Also keep in mind, before adding secondary region, you have to create a primary cluster first. Once it's provisioned, then you can add your secondary region and you can failover manually, or it will failover automatically in the scenario of service degradation. Alright, so let's jump to the next question. Question number 2. A company uses an organization in AWS organizations to manage AWS accounts that contain applications. The company set up a dedicated monitoring member account in the organization. The company wants to query and visualize observability data across the accounts by using Amazon CloudWatch. Which solution will meet these requirements? Let's evaluate each option. Option A. Enable CloudWatch cross-account observability for the monitoring account. Deploy an AWS CloudFormation template provided by the monitoring account in each AWS account to share the data with monitoring account. This solution allows the monitoring account to query and visualize observability data across multiple accounts using cross-account access. Deploying an AWS CloudFormation template provided by the monitoring account in each AWS account helps set up the necessary and configurations to share data with the monitoring account. So, this is the correct answer. Option B. Set up service control policies to provide access to CloudWatch in the monitoring account under the organization's root organizational unit. Service control policies control permissions in the organization and are not designed for enabling cross-account access to CloudWatch data. So this is not the correct answer. Option C. Configure a new IAM user in the monitoring account in each AWS account. Configure an IAM policy to have access to query and visualize the CloudWatch data in the account. Attach the new IAM policy to the new IAM user. This option involves setting up IAM users and policies in each account individually, which can be more complex and less scalable than using CloudFormation templates for centralized management. So this is not the correct answer. Option D. Create a new IAM user in the monitoring account. Create cross-account IAM policies in each AWS account. Attach the IAM policies to the new IAM user. Similar to option C, this involves creating IAM policies in each AWS account, which can become cumbersome and is less centralized compared to CloudFormation template approach. So this is also incorrect. For centralized management and efficient cross-account access, CloudWatch data, option A, enable CloudWatch cross-account observability is the most appropriate choice. This approach aligns with best practices for cross-account access to observability data in AWS organization. Alright, so let's understand CloudWatch cross-account observability with the help of diagram. This diagram shows how EC2 instances, ECS Fargate and Lambda functions from three different AWS source accounts are monitored centrally by Amazon CloudWatch cross-account observability. The box in the bottom is AWS centralized monitoring account. Source accounts share their data with the monitoring account. Cross-account tracing aggregates traces from multiple sources accounts into a single monitoring account. This enables a complete view of requests that travel across multiple accounts. Let's dive into the console and explore how to set up CloudWatch observability. Alright, so this is CloudWatch dashboard. Navigate to the settings. So from here we can configure centralized monitoring and even we can set up source account configuration. So if you click on configure, in this section you can list the account, organization path or organization IDs to the account that will share data with the monitoring account. You can separate all the values by providing the comma as you can see in the example. Alright, so let's jump to the next question. Question number 3. A company developers want to secure way to gain SSH access on the company's Amazon EC2 instances that run the latest version of Amazon Linux. The developers work remotely and in the corporate office. The company wants to use AWS services as a part of the solution. The EC2 instances are hosted in a VPC private subnet and access the internet through a NAT gateway that is deployed in a public subnet. What should a solution architect do to meet these requirements most cost effectively? Let's evaluate each option. Option A. Create a bastion host in the same subnet as the EC2 instances. Grant the EC2 create VPN connection IAM permission to the developers. Install EC2 instance, connect so that the developers can connect to the EC2 instances. This involves creating an additional instance bastion host in the same subnet, which may add unnecessary cost and complexity. It also requires the developers to manage additional components, so this is not the correct answer. Option B. Create an AWS site-to-site VPN connection between the corporate network and the VPC. Instruct the developers to use the site-to-site VPN connection to access the EC2 instances when the developers are on the corporate network. Instruct the developers to set up another VPN connection for access when they work remotely. While site-to-site VPN is a valid option, it can be more complex to set up and may involve additional cost. It might be overkill for a scenario where a more straightforward solution like System Manager is sufficient. This one is also incorrect. Option C. Create a Bastion host in the public subnet of the VPC. Configure the security group and SSH keys of the Bastion host to only allow connection and SSH. Authenticate from the developers, corporate and remote networks. Instruct the developers to connect through the Bastion host by using SSH to reach the EC2 instances. This option involves managing a Bastion host and configuring security groups and SSH keys, which can add complexity. It's also less cost-effective than using AWS System Manager. This is also incorrect answer. Option D. Attach the Amazon SSM Manage Instance Core IAM policy to an IAM role that is associated with the EC2 instances. Instruct the developer to use AWS System Manager's Session Manager to access the EC2 instances. AWS Systems Manager Session Manager allows secure and auditable access to EC2 instances without the need for the Bastion host. The Amazon SSM Manage Instance Core IAM policy provides the necessary permission for System Manager. It cost-effective and simplifies access management. So, this one is the correct answer. Let's jump into the console and explore the process of accessing an EC2 instance using Session Manager. Alright, so we are logged into the console and this is Systems Manager dashboard. Locate Session Manager from left navigation pane. So here is Session Manager. Let's click on it. In the Session Manager dashboard, select the Session Manager option. Here you will find list of managed instances. So click on Start Session. Choose EC2 instance you want to connect to. Click on Instance Name and you can start session from here. But before that, ensure your EC2 instances are set up with the necessary IAM role. For Session Manager, create an IAM role with the policy Amazon SSM Manage Instance Core attached. So let's jump into the EC2 console where I will show you the role which I attached to the EC2 instance. Alright, so this is the instance which is currently available in Session Manager dashboard. So click here. Scroll down. As you can see, this is the role is associated with this instance. So let's click on the role. Alright, so this role is currently associated with our EC2 instance, and as you can see, Amazon SSM Managed Instance Core permission is currently attached with this role. So ensure your EC2 instance are set up with the necessary IAM role for Session Manager. Alright, so let's take the session by clicking on Start Session. This initiates a secure connection to your EC2 instance without the need for open inbound port for SSH keys. Alright, so new window is open, providing you with a secure shell or SSH into your instance. You now have command line access to perform tasks directly with the AWS Management Console. So you can perform your desired tasks such as troubleshooting, software installation or configuration changes directly through the secure Session Manager connection. All actions are logged for auditing purpose. As you can see, it is basically showing all the directory files which are currently available within my EC2 Windows-based instance. And once you have completed your task, simply close the session window. This secure connection is terminated, leaving no open port and reducing your attack surface. So let's close this connection by clicking on Terminate button. Alright, this is it. So let's jump into the next question. Question number 4. A data analytics company has 80 offices that are distributed globally. Each office hosts 1 petabyte of data and has between 1 and 2 Gbps of internet bandwidth. The company needs to perform a one-time migration of a large amount of data from its offices to Amazon S3. The company must complete the migration within 4 weeks. Which solution will meet these requirements most cost effectively? Option A. Establish a new 10 Gbps AWS Direct Connect connection to each office, transfer the data to Amazon S3. This option might incur high cost, and the time required to set up a new 10 Gbps direct connect connection to each of the 80 offices may not align with the 4-week migration time frame, so this is not the appropriate choice. Option B. Use multiple AWS Snowball Edge storage optimized devices to store and transfer the data to Amazon S3. AWS Snowball Edge is designed for large-scale data transfer. It allows you to ship physically devices to each office, enabling the efficient transfer of data to the devices, and then shipping them back to AWS for ingestion into Amazon S3. This method can be cost-effective and parallelized across multiple offices. So this seems to be the correct answer, but before making the choice, let's discuss more available options. Option C. Use AWS Snow Mobile to store and transfer the data to Amazon S3. AWS Snow Mobile is designed for exabyte scaling data transfer, and it may overkill for a 1 petabyte migration from each office. It is also more specialized solution that might not align with the cost effectiveness requirements. So this is not the correct answer. Option D. Set up AWS Storage Gateway Volume Gateway to transfer the data to Amazon S3. AWS Storage Gateway is typically used for hybrid cloud scenarios and may not be the most efficient for a one-time migration of this scale. It involves ongoing data synchronization and may not meet the 4-week time frame. So this one also incorrect choice. For cost-effective and timely one-time migration, option D. Use multiple AWS Snowball Edge storage optimized devices is the most appropriate choice. It allows for efficient data transfer and parallel across multiple offices, and physical shipping of devices helps to overcome bandwidth limitation. Alright, so let's understand Snowball. This diagram illustrates the architecture commonly used for migrating data from on-premises data sources such as NAS arrays, databases, data warehouses, or other storage systems to AWS using Snowball Edge. The Snowball Edge storage optimized device has a raw storage capacity of 100 TB with a built-in Amazon S3 compatible endpoint, Amazon EC2 compute, and block storage capabilities. This architecture uses a temporary staging workstation. The workstation mounts the data source using the NFS or SMB protocol. For migration of data from Hadoop or other file systems, the architecture enables the use of native connectors and libraries on the staging workstation to mount the data source. So the correct answer is Snowball Edge. Question number 5. A company uses high concurrency AWS Lambda function to process a consistently increasing number of messages in a message queue during marketing events. The Lambda function uses CPU-intensive code to process the messages. The company wants to reduce the compute cost and maintain service latency for its customers. Which solution will meet these requirements? Option A. Configure reserved concurrency for the Lambda function, decreases the memory allocated to the Lambda functions. Configure reserved concurrency helps control the number of concurrent execution, but decreasing memory might negatively impact CPU-bound workloads. It's usually more effective to increase memory for CPU-intensive tasks, so this is not the correct answer. Option B. Configure reserved concurrency for the Lambda functions, increase the memory according to the compute optimizer recommendations. Reserved concurrency allows you to limit the number of concurrent executions, helping to control costs during high concurrency events. Increased memory can improve CPU performance for CPU-bound tasks. AWS Compute Optimizer recommendation can guide you on optimizing the memory setting for better performance. This seems to be the correct answer, but we will discuss available options as well. Option C. Configure provision concurrency for the Lambda function, decrease the memory allocated to the Lambda functions. Provision concurrency ensures a specified number of concurrent executions are available, but decreasing memory might impact the performance of CPU-intensive tasks. So this is not the correct answer. Option D. Configure provision concurrency for the Lambda functions, increase the memory according to the AWS Compute Optimizer recommendation. While provisioned concurrency can help maintain a set number of concurrent executions, Increasing memory is likely to improve the performance of CPU-intensive tasks. The choice between option B and option D might depend on specific details of the workload, the nature of the CPU-intensive task, and any observed performance improvements. Both options aim to provide better control over concurrency and memory to meet the requirements of reducing compute costs and maintaining service latency high concurrency events. For cost effectiveness and maintaining service latency, option B is the recommended choice. This allows you to control concurrency and optimize memory for better CPU performance based on AWS Compute Optimizer recommendations. Alright, so let's dive into the console and explore how to set a reserved concurrency for Lambda functions. Alright, so this is Lambda function configuration page. You can find the concurrency section. This is where you will set the reserved concurrency for your function. Let's click on configuration. Here is concurrency. Click edit. Select reserved concurrency. You can enter the desired number of reserved concurrency like 100. This represents the maximum number of concurrent execution for function is allowed to have. Consider the overall capacity of your AWS account and distribute reserved concurrency wisely among your Lambda function to ensure optimal resource utilization. Save your changes. Your Lambda function is now configured with reserved concurrency, providing dedicated resources and predictable performance for critical workloads. By configuring reserved concurrency for your Lambda functions, you have taken a strategic step to control resource allocation and ensure consistent performance for your serverless application. Alright, so this is it for today. Thank you all for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill, so review the course content and keep practicing with 591 Lab help and support. If you have any questions or concerns, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.